Let's use some identities here, huh? Let's go mess around. This might be similar to something you might see. That's kind of similar. Right back to it. Sine squared of theta plus cosine squared of theta is equal to 1. Big concept. We got to know it. We got to know that sine over cosine, that's just tangent, right? We got to know, what is it, 1 over sine? That's cosecant. 1 over cosine, that's a secant. And what's cotangent? Cotangent would be cosine over sine is equal to cotangent. So there are our 4 trigonometric functions that aren't sine or cosine. But notice, they're all made up of sines and cosines. So as long as you know sine and cosine, you've got everything figured out. So this is one of our first games we're going to start playing. So with this amount of information sitting here, this will be your first sort of foray into what we call trig identities. There's some of the toughest stuff we do in the whole class. On exam 2, it's about 20% of your grade, and on your final exam, it's about 20% of your grade. So it represents a large portion, and we're going to slowly start building you up now. So at first, it's definitely going to feel a little bit challenging, but let's keep it mellow. So an identity means you're not solving anything; you're just showing it's the same thing. Now, these are the types of things that I would ask you to do a quiz on. And in one of these videos, probably very shortly, I'm going to give you a quiz. I'm just going to say it right in the middle. But not in this one, not in this one. So we're just going to go through and I'll show you kind of how to play some of these games. Now, here it is. We want to use identities. This is the wording that are our trig identities to transform the left side of the equation to the right side. So this would be your lead in. This is what it's going to ask you to do. And I'm basically doing the problem right before your problem in your homework. So tangent of theta times cotangent of theta is equal to 1. So this would be an example of one of the problems. There's nothing to solve. There's no answer to this. All it's asking you to do is take the left-hand side and show us the same thing as the right-hand side. You're going to play this game a lot. You're not going to do any algebra to it. You don't multiply by anything. You just reduce it down. Here is our game. We look at this, and you can be a pro with this game if you just turn everything into sine and cosine. Look. Tangent. Tangent. Tangent, sine over cosine. So we're going to rewrite tangent. Sine over cosine. Cool. Where's cotangent? What's cotangent? Oh, cotangent's right here. That's cosine over sine. Oh, shoot. You mean the reciprocal that just flipped over? And then do you know what you can do in fractions? You ever seen this in fractions? Because with multiplications in this, you could actually just connect this across and just do this and call them multiplications. Yeah? You know that. Numerators with numerators, denominators with denominators, that's how we multiply this shit. And anything that matches top and bottom, you can cross it out. Sines and sines, gone. Cosines and cosines, gone. Now, it doesn't turn into 0. It turns into 1. Hooray, we did it. We got everything to cancel out. Right? Because sine divided by sine is 1. Cosine divided by cosine is 1. Maybe I clean it up just a little bit more so you can see it. But like, take this sine and you got the cosine on one side, and then turn these two around. Now you got sine over sine and cosine over cosine. Well, shoot, that's got to be 1 times 1, which equals 1. That's how we do these little identities. We just mess with one side. And for right now, all I want you to do is play the game. As long as you know that everything's built from sines and cosines, shit, you're unstoppable. You're unstoppable. Now, you have a beast of a homework problem. And I'm actually going to do it right now for you. So if you're hanging in there and watching this, this is probably going to be one of the toughest homework problems that you have. And if you don't watch this, I imagine it's going to be a huge pain in the ass. So let's do it. Let's do this problem right now because it's got a couple extra things in it. So our second little one, we're going to say it's tangent of, and it gives you this weird thing, beta. And it's all scaring you like, oh, it must be something different and whatever. whatever. It's just a picture we use. Oh. And they claim that this is equal to cosecant squared of beta. Oh my gosh, huh? That's a heck of a thing. And we want to take the left-hand side and make it look like the right-hand side? I think we can do it. Now this is too much too soon, and that's why I'm showing it to you. It's too much too soon. Down the road, by the time you take exam 2, that you can crush this, cool. Right now, you can just follow what I'm doing and punch in the answer and follow right along. So what we're going to do is we're just going to replace everything and turn it into sines and cosines. So instead of writing in our tangent of beta, I'm going to put in sine of beta over cosine of beta. And we just replaced it. Cool. Now we go to our cotangent and we replace cotangent. And cotangent is cosine over sine. Cool. Lastly, let's go down to our denominator and we'll place that in and we'll change this to a sine of beta over cosine of beta. There's a lot going on, but all we got to do is just focus. We don't want to mess around with the denominator yet. It's up top. It's up top. We want to do this. I mean, we got a couple tricks right now. We could either multiply by the least common denominator, which is a great little trick. I like this one. See the cosine, sine, and cosine? That's the denominators we're talking about. What's the least common? Basically, how the hell can we get rid of all those damn fractions? What do you think we could multiply by to make sure that we guaranteed that we'd get rid of all of those fractions? We multiplied top and bottom by it. Well, that would be sine of beta, cosine of beta, top and bottom. That'd be multiplying by 1. If you like that trick, go for it. I'm not going to really show it that way though, okay? But that's the least common denominator. I love that trick, and it does work. So if you're one of those that's using it, but I'm going to show it in just a different way. I'm going to just look at the top. Just the top, sine of beta, cosine of beta, plus cosine of beta over sine of beta. Let's create a common denominator. Let's give it a sine of beta and a sine of beta. And then down below for the other ones, we're just focusing on these two. We're not focusing on the bottom right now. We just got to put it together. And to make it match, now this has a sine beta cosine. The other one needs that cosine beta, cosine beta. Now see, that's why I'm saying you got to be able to add fractions with numbers. Now we're doing it with freaking words, dude. This is too much too soon. Too much too soon. But that's what we do to STEM majors. You got to be uncomfortable every once in a while. So we write in our sine of beta, cosine of beta. And what do we got up top? Let's replace. So sine, cosine. Sine beta, cosine beta. And that was sine times sine is sine squared. Plus, and now the other one, we have our sine beta, cosine beta. And then we have cosine times cosine. That's cosine squared of beta. Well, shit. We did this so we could get a common denominator so we could put it all together, right? So I know you don't want to write all these steps, but I don't mind. I can do it. So when we put this together, since we have that common denominator, both these are the same, even though my writing sucks and it's hard to read it. They're both sine beta, cosine beta. So that's our common denominator, and now we can just add these two together. So there it is. We get our sine squared of beta plus cosine squared of beta. Hooray. Oh, dang. Hallelujah. Now we can clean stuff up. Aren't you glad I'm doing this problem with you? You know what I mean? This one's rough. Well, what's sine squared plus cosine squared? What's sine squared plus cosine squared? Sine squared plus cosine squared equals 1. We got there. Ooh. Let's go. So now we have that it's, instead of that was 1 over sine beta cosine beta divided by sine of beta cosine of beta. Oh gosh, and now we can go old school. We're not going to get freaked out here. We're going to be like, no, dude, it's this fraction up here divided by that fraction there. So 1 over sine beta cosine beta divided by whatever's down below, sine of beta cosine beta. We're almost there. We are almost there. So this is equal to 1 over sine beta cosine beta times, we flip that shit over, right? That's the division. We flip it over. Cosine beta over sine beta. And then we go a little hiya, hiya. Those cosines and betas go away, just leaving us with 1 over sine times sine. That's 1 over sine squared of beta. And you know what that freaking equals? 1 over sine. That's cosecant. But since it's all squared, we get cosecant squared of beta. Yeah. Yeah. I'm sorry about that. I know that was cruel. I put it in your homework. I knew it was rough. But here's the answer. This is how you go through it. If you can follow along, that's terrific. If you can't follow anything, please don't be discouraged. This is too much too soon. Do not be discouraged if you looked at that and went, I don't know what the F you're doing. That's cool. Give it time. This is just leading you up to something that we're going to do for exam 2. This is actually an exam level problem I gave you right here for exam 2. But you just get to see it, get a little frustrated, and know that you have time to get better at this. So this one, let it go if you didn't follow anything. This one back here, the tangent times cotangent, get that shit figured out. This one here, whatever. Whatever. Do your best. All right. See you in the next.